I will give the word to Jiří Liška, who is a junior researcher in the group of Professor Tomáš Šikola of fabrication and characterization of nanostructures. And he will introduce selected types of nanostructured platforms that can be fabricated in CEITEC Nano laboratories. So, Jiří, you can go on.
Okay, good morning. Thank you for the nice introduction. I will tell you about our nano platform for biosensing application, which we are developing. I will start with the idea which is behind the nano sensor. Question first, how can we catch a mammoth in a free space? We can use a big hole. How can, it's fantastic, it works well. However, also a small rabbit is caught in the hole. Question 2, how can we catch a rabbit in a free space? Can we use the same big hole? No, if we don't like to catch a rabbit. So what about using a much smaller hole? Great, it's great success. The rabbit is caught, tie them, and the mammoth went around the hole and stay free. Why? Because we get a perfect match between size of a rabbit and size of a hole. And this is the key of this presentation. Question 3, how can we catch a virus, proteins, and similar nanoparticles in a solution with many other larger particles? We can use nanovels and tune their sizes to get match with sizes of nanoparticles. I will talk about nanoparticles or nanostructures, so just really briefly, these are objects with one dimension at least below 100 nanometer. We can make a lot of applications of these nanostructures, nanoparticles from socks with special protection, or coatings on cars, for example, or field effector transistors. From that time that people start to study nanoparticles or nanostructures, start thinking also about helpful or harmful the nanoparticles for the human. I will just put one picture, which can be classified as self-formed nanoparticle nanostructure as proper range. I think it's not necessary to comment more about this. I am belonging also into the subgroup of plasmonics, which means study of interaction between light and matter in nanometer scale, and we usually working with nanostructures like this. It means some disks, cylinders, or nanocones in arrays, and thanks to this project, we also are familiar with nanovels or combination with these structures. When the structures are made from gold, silver, or some other materials, we can obtain nice properties because it behaves like nano antenna. Thanks to this, we can focus light, electric field, magnetic field, but also use as sensing element. And this is good for us because when we combine gold disk with nanovels array, and it has good properties, for example, height or diameter of nanopores around nanovels around 100-200 nanometers, we can get a lot of benefits. About filtering using different size of particles, I talked before. We can record also particles which go down to the nanovels. This is label-free technique, which is very nice for sensing applications. And after tuning of nanovels sizes, we can get sensitivity on the single particle, which is also very nice. Yeah. How can we prepare some platform? We can use several fabrication steps: electron beam lithography, deposition, etching, and finally we are able to observe or to get nanostructures like this. And how can we check that the idea is working? We can use commercial SPR sensor and put them the microparticles, nanoparticles, or their mixture in the solution, and you can see nice response. In our case, Nanovell's platform is situation more complicated because we have to measure very small light changes, color changes, and we need a spectroscopy. For example, the nanoparticles are here, the small dots. About real application, we would like to use it for endotoxin detection. We selected lipopolysaccharides, which are parts of gram-negative bacteria, and we plan to use it in the complex solution. So our future plans is improve the stability and sensitivity of our detector, testing of the endotoxin detection, and also we would like to put inside not nanodisk but nano cones. The fabrication is optimized, and this should help us to answer on the question where the particles are bound, if the bones to the top or in the bottom of the glass. So I would like to thank all the research projects, financial support, and also the colleagues from our group or nano staff.
Okay, thank you, Jiří. I would like to ask everyone for questions. There are.
May I have one? I would like to ask about the specificity of this test. You were talking about some bacteria recognition, and how do you ensure that you will recognize only, I don't know, certain type of bacteria and not the others? Is there any possibility of specificity of this test, or it just get all these bacteria?
One thing which can help is the size of the structures, but in case of the plenty or large distribution, it will be more complicated. However, each particle would influence in different way a little bit because it depends on the local refractive index. So there is some way how to differentiate it.